Okay, so remember next Friday, so a week from today's, we're gonna have a chapter test on statistics. Okay, we have two more new lessons that we have to do. This is one of them. Okay, so today after today, we'll only have one more. So next week we'll practice a little bit on this, review, do the new lesson, review, and then take the test. Okay, that'll be the last 100-point chapter test. The week after is our last week, right? So Monday and Tuesday are regular days. Monday and Tuesday are regular days. Review for the final. I'll give you a worksheet, a chapter or a final review, so that you'll know exactly what's going to be on the final. Gives you 2 days to get your notes together. Gives you 2 days to ask questions, get everything in line, and then I believe this class we will have our final on the 9th. This class will have the final on the 9th. I won't see you on the 8th because you'll be going to other classes. Because the last 2 days are block to give you time to do the final. Okay. So Monday and Tuesday, this is not next week. Next week is up here. Monday we have off. Tuesday, Wednesday, Thursday, we're going to finish the chapter, review for the chapter, the third test. And then the last week, Monday and Tuesday, regular days, regular scheduled days. We're going to review for the final. I'll give you that's all we're going to do. Nothing new. That's it. Review for the final. I'll answer any questions you have. You get your notes all ready to go so that the 9th, you take the final, you're done. The final is only 15 questions. It's not long. I do that on purpose because I want you to finish. I don't want you to have to come back and take it, because there is no time to come back and take it. After the 9th, I won't see you guys because it's summer. Okay. So, um, yep, that's that. So today, what we're going to do today, we're looking at something called normal distribution. Okay, normal distribution, which is so how does this relate to what we've been doing? Well, we've been looking at distributions or shapes that are symmetrical or skew, right? Skew to the right, skew to the left. They look like this, right? We've had things that when the data is on the low side, it's skewed to the right. You know, when most of the data is on the low side, like a hard quiz or a hard test, most of the scores on the low side, right? Not too many on the high side. So it's skewed to the right. Opposite is true over here. Skew to the left means test was really easy. Most of the scores were on the high side. There are some on the low side, but not as many. Then we have symmetrical, where the most of the data is in the middle. Symmetrical down here, but it's called bimodal because there's two peaks. Okay. What we're going to look at today is we're going to focus on this guy here, where one peak and it's in the middle. It's symmetrical. So if I were to cut this in half, it would be exactly the same on each side. Okay. That's what we're going to focus on today. It's called normal distribution. So for it to be normal, a couple things have to be true. First of all, the mean and the median are exactly the same. They're exactly the same. So if you know the mean, you're also going to know the median. Okay. Most of the data are clustered near the mean, near the middle, right? Most of the data, because that's where the height is, right? As I go to the sides, it gets lower. Okay. So most of the data is in the middle. That's the second thing. Let's see. It's symmetrical, right? If I cut it in half, we just said that. If I cut it in half, this side over here would look exactly like this side. Everything would fit. Okay, it's symmetrical. If it happens on one side, it also happens on the other. As I go farther and farther to the right, so what does that mean? So as I go, so if I start in the middle here, as I go this way, the height goes lower, right? So that means less likely to happen, right? Less data out there. Less data out here, less data out here. As you go farther and farther to the right and farther to the left. Okay? Okay. Sometimes it's called the normal curve because it's a curve, right? Bell-shaped curve. The reason it's called the curve, or the reason why it's called curving a test, comes from this, right? We kind of talked about that. What does it mean to curve a test? Well, it's based off of this. Okay. Okay, so that's what normal distribution is. Now we're going to focus on something called the empirical rule. Okay, the empirical rule has these percents in it. Okay, so what the empirical rule says is you have a mean. The mean's in the middle. For a normal distribution, the mean is always going to be in the middle. Okay, and then you have variance, right? To the right or to the left. Well, the mean plus one standard deviation and minus one standard deviation, 68% of the data is in the middle, in there. So from one standard deviation to two standard deviations, 68% of the data. That's most. That's more than 2/3. That's all. That's most of the data. So over 2/3 of the data are close to the mean in here. That's why the peak is so high. There, kind of tails off after that, right? That's the first thing. The second thing is two standard deviations. So two above and two below. 95% of the data are from there to there. 95% of the data are from +2 to -2. That's almost everything because there's only 100%. Can't go over 100%. So 95% are from +2 to -2 standard deviations. And then the last one is +3 and -3. +3 goes all the way out to the edge here. -3 goes all the way out to the edge over here. Almost everything is between -3 and +3. 99.7. That's almost everything. Okay. Almost 100%. So almost all of the data is from -3 to +3 standard deviations. The widest we're going to go. Okay. So that's what the empirical rule. This is the empirical rule. This is what the empirical rule says. It says 68% of the data, 60% and 75% of the data, 95% of the data, 99.7. That's the rule. So what we're going to do is I'm going to cut this up a little bit, okay? Because it's going to make it easier on you today. Trust me. This part here, this next part is probably going to be the most useful thing you're going to have today because it's going to help you. Okay, so we have another one like that, but it doesn't have anything on it. Just has some tick marks at the bottom. Well, the first thing we always do is cut it in half. So the mean is right here. So I'm going to cut it in half here. That's where the mean is. Now take an educated guess. What percent do you think is over here and what percent do you think is over here? 50-50. Makes sense, right? If it's in the middle and it's symmetrical, if 50% is over here, then 50% has to be over here too. That's right. 50-50. Okay? Okay, so let's break it up a little bit more. So let's go one standard deviation above. So if I was to add a standard deviation and then do the opposite, subtract the standard deviation. Okay, I'm going to shade it. You don't have to shade it. You can if you want to, but I'm going to shade it for a reason, and I'll tell you right now once I shade it. Okay, take an educated guess. I don't want just a random guess. I want an educated guess. What percent do you think the yellow represents?
68% on the diagram.
Yep, the diagram right above, right? Says, how far is it from -1 to +1? -1's here, +1's here. So all of this in here is 68%, right? Okay. So we're going to cut it up a little bit though. How much do you think is in each of those yellows? Educated guess. 34, right? Because it's symmetrical, and this is the half. So that means this side, this side over here has to be the same as this side over here. So it's going to be 34 and 34. Because together they equal 68, and it's symmetrical, so it's half and half. Okay. Let's go another standard deviation out. So 2 plus 2 and minus 2. So plus 2 standard deviations, minus 2 standard deviations. Okay, so now I'm going to shade this area here and this area here. Okay. Educated guess, or not I don't want to guess it. I don't want any educated guesses yet. No numbers. I don't want numbers right now. Tell me what you know about the blue and the blue. That they're exactly the same. Good. They have to be exactly the same, right? Because they're both on opposite sides of the middle. So they're exactly the same. So whatever we get in one, we know we're going to get in the other. What else do we know about it? For we know they're the same. What's another thing we know about the two blue parts? We know 95%, right? We know something about 95%. Good. But before that, even less, is it going to be more or less than the yellow? Less. It's smaller, right? As we get further away from the middle, it goes down, it's smaller. So it's going to be less. So someone last class said, oh, 40 something percent goes in there. I'm like, does that make sense that 40 something percent is going to go in there? No, right? What do we know about 95? Yeah, Javier, you brought up 95. What do we know about 95? 95 is related to these two.
From -2 to 2.
Is 95, right? So does that mean we divide 95 by 2? No, right? Because isn't all some of that already taken? How much of it is already taken? 68, right? So let's subtract 95 from 68, and what do we get? We get 27, right? But there's two sections, right? So does 27 go in here and 27 go in there? No, they have to share, right? So how do we figure out that? Divided by 2. And when we divide it by 2, we get 13.5. So that's what's going to go in here. 13 and a half, 13.5%. How do I know that's right? Because if I add up 13.5, 34, 34, 13.5, what is it going to equal? If I add it all up, if I add the blues and the yellows, 95. Yeah, if I add the blues, it gets me 27%. If I add the yellows, it gives me 68. If I add them together, I get 95. And according to my diagram up here, from -2 to +2, it has to be 95. Okay, so let's go out another one. Let's go out the last one. +3 standard deviations and -3 standard deviations. So let me highlight that a different color. Again, what do we know about it? It's bigger or smaller than the blue and the yellow? Smaller. As I go towards the edges, it gets smaller, okay? Are they the same size? Are the two tan areas the same size? Yeah, because they're symmetrical, right? Okay, so how do I figure out what those what's going to be in the tan area? Say again? Close, not 100. There you go, right? From -3 to +3, was 99.7. That's pretty close. That's very close to 100, but it's actually 99.7. So we have 99.7 minus, how much do we already have labeled in red? There you go. So how much do we have here? You're right. What number is that? 95. So we have 95 already labeled. We have 99.7 that we have left, that we're trying to figure out what's left over. 4.7, right? So does that mean 4.7 goes in each? Half it again, right? We got to half it because it's got to share. So that is going to be 2.35%. Okay. So if I was to add up all of the red numbers, 2.35, 13.5, 34, 34, 13.5, 2.35, would I get 100%? No, I get very close. There's percents that's missing. How much is missing? 0.3, right? This 0.3 over here, 0.3. So that's how much is going to go in here. The so small part that it doesn't even shade, because I can't fit a shade because it's so small. What percent goes in each of those? Divided by 2. Yep, 0.15. Very, 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 very tiny. So small that if you were to take a penny and cut it up into 100 equal pieces, it would be worth 15 of those. You can't even buy anything with a penny, let alone 15% of a penny, right? That's how small that is. It still counts, but it's very small. Okay? This is the empirical rule. This is the empirical rule. The empirical rule says 38%, or sorry, 68% has to be between -1 and +1. 95% has to be between -2 and +2. 99.7 has to be between -3 and +3. And then the rest can split on each side. 0.15. Okay? So we're going to use this on the next one. So now we're going to turn it over or open it up. Let's look at the first problem. So these are all context problems. Context means there's a story behind it. They're not just random numbers. This is actual data. Okay, so the amount of time a certain brand of light bulb lasts is normally distributed and has a mean of 1,400 hours and a standard deviation of 50 hours. Okay, so this brand of light bulb, it says it lasts on average 1,400 hours. So does that mean if I were to go to Home Depot, Lowe's, and go buy that brand, and I were to plug it in and I were to time it at exactly 1,400 hours, it would burn out? No, it means on average, right? So I could go buy this brand and it could last less than that. It could last more than that, right? If I'm lucky, more, if I'm lucky, less. It's on average, right? It's on average. 1,400 hours is about 58 days, 59 days. Not that long. Less than 2 months. Okay? So that number varies by 50 hours. So if you're lucky, you get an extra 50 hours or more. If you're not lucky, you get less than that, right? So what we have to do is, using the empirical rule, using this guy here, we have to figure out the interval. Interval means beginning to end. Our interval for this class right now is 10:50 to 11:45. That's our interval. It's our start to our end, right? So that's what they're asking. Where's the start to end for the middle 68% of all of these light bulbs? Okay, so when you do this, first thing you're going to do is you're going to highlight, underline, circle, box in the mean and standard deviation, because those are the two guys you're going to be using the most. Okay, so highlight, underline, box, circle, whatever you need to do. That's the first step. Second step, we're going to draw and label one of these guys. We're going to draw and label one of these guys for this problem. Some of you are like, well, we already did that. We just did that. Why do we need to do it again? We didn't do it for this problem. This problem is going to be unique. It's going to look like this guy here, but it's going to have different numbers because it's a different problem. Okay? So what you're going to do is you're going to draw the best you can. You're going to draw a normal curve. Okay? Best you can. You get better as you go. I've been doing it for 9 years, and that's how good I can do it. Not very good. Okay? Just do it the best you can. Doesn't have to be perfect. What was I going to say? That's the normal curve. Okay? The first thing you always label, because that's drawing it. Labeling means put numbers, put things in there. We're going to cut it in half. That's the mean. I'm not going to write the word mean in there because this one actually has a mean. What is the mean on this one? So I'm going to put 1,400 under there. Okay. So now I'm going to go +1 standard deviation, +1 standard deviation, and -1 standard deviation. Okay, so now I have to figure out what numbers are under there. Okay, so to the right is plus, right? So I need to add 1 standard deviation. I need to add 1 standard deviation. Well, how many is 1 standard deviation? 50, right? 50 hours. So I'm going to add 50 to this. There you go, 1450. That's +1 standard deviation. I'll put a +1 under here so that we know it's +1. Okay. Let's go, and then over here to the left. This is not +1. This is going to be -1. So instead of adding 50 like I did here, I'm going to minus 50. So it would be 1,350. Yep. Okay. Go 2 more out. -2 and +2. +2, -2. So to get to +1, I added 50. What do you think I'm going to do to get to +2? Add another one, right? Add another 50, right? Because this says add 150. This said adds 2 50s now. So 50 and another 50 would be 1,500. Same thing over here, but subtract. Take away a 50. Take away another 50. So it would be 1,300 right on the dot. One more. +3 -3. So I added 150. I added 2 50s. Now I got to add another 50. So that's 1,550. Okay, so that's number 2. That's step 2. Okay, draw and label. Step 3, shade. Shade in. What do we shade? What they want us to shade. So the question revolves around what? They want the interval that represents the middle 68%. Okay, so let's go back over here to our one we did earlier. The middle 68% goes from what to what? From -1 to +1. So that's where we're going to go shade. We're going to shade from -1 to +1. Okay, that's the middle 68%. Now, interval means where does it start? Where does it finish? So where does that start? Where does that shaded part start at? 1,350, and it hours, I should say, to 1,450 hours. There you go. That's where it starts and finishes. If you want, if we a light bulb that finishes in the middle 68% would have to work from 1,350 hours to 1,450 hours. Okay. All right. Okay, let's go to number 2. Okay, so number 2, another question, another a context question. So the context of this one's not light bulbs anymore. It's heights of boys, high school boys, in an all boys high school. Okay. What's that? What, all boys high school? Oh.
You could have at least put young men.
Oh, okay. Yeah. Oh, you're talking about all boys?
Boys.
It's what it's called. I'm sorry. I'm sorry if that hurts your. No. I don't create these. No, this is real data. So there's a real all boys school, all young men school. Okay, somewhere they measured the heights of all of the young men that go to this school. Okay, I know. And the average height was 68 inches. That's their average height. That's 5'8". 68 inches is 5'8". Okay. Now, not every young man is 68 inches, right? Not every boy is 68 inches at this school. Now, we're not talking, this is not an all boys school. So this is not you guys. This is some other school. Okay. They have all boys and all girls schools. They're usually private schools. They have some in like San Francisco area. They have some in like the LA area. They're usually religious schools that have all boys schools or all girls schools. They are, but they're not real. They're not. There's not a lot of them. There's just not a lot of them. Okay. Most schools nowadays are co-ed. They have boys. They have all genders. Okay. Okay. So blah, 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 blah. Okay. So not every boy at this school though is 68 inches. That's just the average. Some are taller, some are shorter. So that's why we have a standard deviation. So here, let me ask you a test question. Before we even get to this question, let me ask you a possible test question. Let's say there's a high school, all boys high school, and every single boy at that school is 68 inches. Nobody's taller, nobody's shorter. It's a weird school where everyone's the same height, everyone's the same 68 inches. What would the standard deviation be? Zero, yeah. There would be no standard deviation because everyone's the same, right? Everyone's the same. That's like if we took a test and everyone scored 100% on that test. Everybody. That would be a standard deviation of 0, right? Okay. All right. So there we go. So the question says, what percent of the boys are between 54.5 and 81.5? So that's 54.5 is very short, like 4 and a half, very short. 81 inches is extremely tall. 6'11"? No. 6'9", 6'8", 6'9". Yeah, that's a basketball player, right? So what percent are in between 4'4" and 6'10", 6'9", whatever it is, right? So first thing we got to do, underline, highlight, circle the mean and the standard deviation. So we know what that is. Second thing is, now let's draw one for this one. The picture is going to look the same, but the numbers are going to look different because the numbers are different for every single problem. We start with the mean, the middle. The average for this school was 68 inches. 68 inches tall. Okay. Not everyone at this school, though, was 68 inches. How do I know that? Because there's a standard deviation. So let's go one standard deviation above and one standard deviation below. So how do I figure out how many are one above? Add 4.5. Take the middle, take the mean, and add 4.5. I believe that's 72.5. That's plus 1. Minus 1. I'm going to do the opposite. Instead of adding 4.5, I'm going to take away 4.5. 60, not 64, 63.5. Okay. Let's go one more. Let's go another one out. 2 out. Plus 2 and minus 2. So I added one standard deviation. Now I need to go out another standard deviation. So I'm going to add another 4.5. So that's 70, 77? Yep. And then take away a standard deviation. 59. One more. Plus 3, minus 3. So plus 3 is 80, yep, 81.5. And then minus 3 is 54.5. Okay. All right. So now the question says, what percent? So now they want percent. So we got to look on the inside. What percent are from the interval 54.5 to 81.5, 81.5? Yeah, because that's from here all the way to here. So I would shade in all of this because that's what I'm looking for. I'm looking for that percentage. Now you know that because it's on our this thing here, right? And it's on this thing here. You knew that already, right? But if I would have asked you this question without this picture to compare, you wouldn't have been able to do it as easy, right? Because I get students who try to, do I have to draw the picture? Do I have to draw the picture? I'm like, trust me, it's a lot easier on yourself when you draw the picture. Take that extra 2 minutes to draw and label it because pretty easy now. It goes from -3 to +3. That's 99.7, right? So if you didn't know, you just add up all the red numbers from -3 to +3. This number, this number, this number. Okay. All right. Okay, so let's go to number 3, last problem. It's got a couple parts to it. So let's do the first part together. Again, I don't make up this data. So this is true. Okay. The length of human pregnancies. So the length of time that a female is pregnant from conception to birth varies on an approximate normal distribution with a mean of 266. So the average female is pregnant 266 days. Now, not every female, we talked about this, 7% of births are when they're supposed to happen. When the doctor, that's what the doctor does. So you go to the doctor if you're pregnant, if you think you're pregnant or you're pregnant, like my wife did, she went into the doctor did a pregnancy test, a more thorough pregnancy test than the ones you can buy at the store, and to confirm it. Once they did that, he's like, okay, put it in my computer. So then he added 266, and he's like, okay, this day here. And that's the day that you think that's the day that's the expected due date, right? Only 7% of the births are actually that day, right? Some the rest 93 are either before or after. Because because life happens, right? What's it called? Nature happens, right? We can't control when kids are born, right? Well, you guys are focused on the I'm already past that part. I'm focused on the when the baby is born. Okay? Yeah. I'm focused on when the birth comes. So the birth comes when it comes, right? We can't predict that, right? Um, so some females, some people in my last class, there were some girls who said, "Yeah, I was born 30 days before my due date." Preemies, they were called prematures, preemies, right? Some, yeah, it's 2 months, right? Some are born after. I was born a few days after my due date, just a few days, not too many, right? So it varies. Okay. So the average. So before we do anything, let's find the average. The average date, the average pregnancy is 266 days. Okay. Somehow they got the data from every single woman who's ever given birth. I don't know how they got that, but I guess when they go to the hospital or they put the data in and somehow they got access to it. Maybe that too. Okay. Somehow they got everyone. Okay. Standard deviation of 6 days. All right. So the second thing we have to do is draw and label. So we're going to draw a normal curve. Once we do that, we're going to start with the middle. Okay, so the middle is the mean, 266. Then we go out +1 standard deviation and -1 standard deviation. So +1, -1. So from 266, how am I going to get to +1? What am I going to add? 6 days, yeah. 6 days, because 1 standard deviation is 6. So 266 plus 6 is 272. 266 minus 6 is 260. Okay, so that's from +1 to -1. That's 68% of the data. Let's go +2 and -2. So add another 6, I get 278. Subtract another 6, I get 254. And then the last one, +3, -3. Add another 6, I get 284 and 248. That's it. Now, that doesn't mean every single birth happens there. If you were born 30 days before you were expected, if I subtract 30 from this, that's 236, right? That's over here somewhere. That's over here somewhere. So before we answer the question, what percent is out here? Yeah. So if you're a premature, there's not a big chance that you were premature. If you were premature, it happens, but it doesn't happen a lot. Okay? Doesn't happen a lot. Out of 1,000 births, for every 1,000 people that give birth, 15 of them are that premature. It's not a lot. It's not a lot. It's very, very small. But it happens, right? It does happen. Some of you, it happened to. Not a lot of people, it happens the other way too. I don't think this number here, I think there's a state law that says that women aren't allowed to go past a certain day of being pregnant. What they do is they induce it. Induce it means they get nature going somehow. However, they induce labor. Um, yeah, you guys can look it up on how they do that. I'm not going to touch that. I'm not touching. There you go. On how they induce labor. They'll do that so the woman, because I guess after a certain day, it's not safe to be pregnant for the woman. If you talk to any woman that's been pregnant, they are counting this day down, right? My wife, before this, she was like, I'm ready to be done. I'm ready to get this baby out. Oh yeah. It takes a toll on your body. Yeah. It takes a huge toll on your body. Just ask your mom. Um, but yes. So yeah, I think something like that. They don't let women go past that because they're like, nope, too late. It's too much. We don't want to put the baby at risk. We don't want to put you at risk. So they induce labor. So you give birth. It's like a planned pregnancy. Okay. So some women actually know the date they're going to give because they say like, if I'm not pregnant, if I don't give birth by this day, I got to go into the hospital and they're gonna get they're gonna not take the baby out, but there's a way they can make the process go quicker. Okay. It's safe. It's not like anything crazy. It's safe, and the baby's born, but they don't want to let it go too long. Okay, just for the health of the mother and the baby. They want everyone healthy. Okay. Um. So 16, longest 16. So longest 16%. Where am I looking at on here? Am I looking in the middle? Am I looking on the right side? Am I looking on the left side? If I'm looking for longest 16%, I'm looking over here, right? This is where all the big numbers are, the longest. Okay. So let's go over here. We're going to shade from the right until I get to 16%. So I'm going to shade this. This is like 0.15%, right? Okay, keep going. If I add this percent, am I at 16% yet? I'm here, right? I'm only here. What percent am I in? 2.5, right? So let me shade the next section. I'm not there yet, so I keep shading. So if I add that section in, is that 16% yet? Yes, it is. That's 16% right there. If I were to add this, so if I were to add this section, and this section, I would get 13%. So it goes to +1. All right. So let's answer the question. How long does a female have to be pregnant to fit into that blue area? There you go. So at least 272 days. If they're pregnant for 272 days or longer, they're in the top 16% of longest pregnancies. Okay, two more, we're done. Okay, so now this question says same prompt, just different question. So how many days does the middle 95% of all pregnancies fall? Okay, so the first thing we're going to do is we're going to draw another picture real quick because it's a different section. They're not asking about the same shaded area. We got to shade a different area. So it's going to be the same numbers because it's the same mean and standard deviation, but it's a different question. Okay. So it's the same picture that I had before because it's the same question. Same prompt, I should say, different question. Okay. So now they want us to say how many days does the middle 95% of pregnancies fall? So the middle 95. So let's go back up to our reference curve here. So from the yellow, from +1 to -1, is that 95? No, the yellow is 68. So we got to go out more. So how about if I add from -2 to +2? Yeah, right. -2 to +2 is right here, 95%. So I'm going to shade from -2 to +2. Okay. The middle 95, that's the middle 95%. So my answer is not going to be a percent because they already told me the percent. There you go. So the shade goes from what to what? 254 days to 278 days. It's the interval. Okay. Okay, since we're low on time here, I won't make you draw another picture, but you can answer the question using this. Use this picture here. What percent of pregnancies are longer than 278 days? Yep, 2.5, because it's this part right here and this part right here, right? So those two parts added together, you get 2.5%. Okay. If we had more time, I'd make you draw the picture, but we only have 3 minutes, so I'm not going to make you draw the picture. All right. All right.